I've started the stream. We're gonna wait a little bit. Okay, I'm gonna wait a little bit for people to kind
Hmm.
of trickle in, tune in, etc. And then we're gonna and then I'll. I mean, this is not like that serious, that fast paced. We're gonna like ease in,
Okay.
and we're gonna give it a bit. It'll usually be like probably like we'll probably start like 5:05 or something, like for real. So
Okay.
yeah, let me go
Mhm.
ahead. I gotta go ping people now. So where the hell is this channel? This channel moves every single time in the sidebar, so I gotta figure out what the hell this thing is. Lounge, voice chat, meetups, discussions, feedback, server, announcements. Here it is.
How many people are usually like on the street? 5.
On the stream, usually there's like well, the viewer count usually is between 15 and 35.
Oh wow,
So
pretty
that's
big.
usually what's going on. If you look at the VOD replay, that's about I think we usually get about 100 to 200 views. So I would categorize that as be 20 viewers concurrent and 200 views, 200 unique total.
Mm.
Yeah. Let me hello friend. At everyone, hello. We have a sys design with. Are you like would it be appropriate to call you like early career, new grad kind of thing?
I'm not even new
You're not even new
grad.
grad. Okay, with what are you,
Yeah,
senior, freshman or junior?
I'm in third
Third
year.
year. Okay.
Yeah, coming to third year. I haven't had
Sys
any
design.
co-ops yet, but I've been working part-time at like UBC as like work alert.
Oh,
This
nice.
will,
Okay,
I'm
okay.
working on my third work alert right now at EML as a software.
Okay, okay, cool.
Yes, and
Design
I'm preparing for like an upcoming interview. They said that they're gonna ask me like a small system design, so
okay.
that's why I'm preparing.
Tomorrow, and then I gotta send the link. I have too many things in my thing. Boom. Send now. Publish. Bing bang boom. Okay. That was the at everyone, and then who is this person DMing me? Can't deal with that right now. And then you're chilling, you're chilling. Okay, great. All right, let's take a look. 8 p. Oh yeah. So let's just give it a couple minutes for people to trickle in. I just did the everyone ping because usually like so this isn't my Twitch channel. This is Cookie's Twitch channel. I can't control the notifications, so I can't. I don't really know how that goes on. I don't know who's getting notified. So I usually have to ping people on Discord for them
Mm,
to get for people to get notified. And is my event started? Let me just see. I don't even know. Whatever. Whatever. What is this system design? Yeah, today will be a system design. Today will be pretty chill. Kind of like still in school, by the way. These days, people I've been seeing in general more and more situations where, like even interns or new grads are getting sys design because previously this was more of like a industry thing where after you've been in industry, they want to give you some, like they want to give a bit of a test on the sys design side. But I think now with competition getting more and more stiff, they've been like there's now people asking this for interns and new grad as well. So yes, this is sys design. Where is my I can't see the Discord event. Is it started? I don't even know what's going on, bro. I'm like tweaking. All right, whatever, whatever. The more I try to figure that thing out, I won't get anywhere. Anyways, let's get started. So, let me just make sure my stream volumes are okay. Looks okay. Looks good. Okay, everyone, welcome to this weekend Saturday's installment of Balkan Reviews and hopefully a resume review session as well. I didn't actually check if I have access to the form that Cookie made. If he doesn't, then I'm gonna have to make my own and take ad hoc submissions. So I didn't sort that ahead of time. Sorry about that. But the first hour from 5 to 6 p.m. Pacific, right now we're going to do a sys design. So, you are in the Excalibur, are you?
sorry, what is that?
That's the site we're using for the sys design.
Oh, sorry.
Yeah,
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 yeah.
I
Okay,
am
no,
okay.
yeah, yeah. No worries. Do you want to give a quick little introduction about yourself first before we get started?
Yeah, so hi, I'm Angela. I'm in third year CS and stats. Um, I haven't done like any co-ops yet. I'm searching for like my first co-op. I have an upcoming interview with Gojen. It's an SF startup, and they said that they're gonna ask me like a small system design. So that's why I'm preparing for that.
Awesome. Thank you. I will be monitoring the chat as we go. Discord event just ended. That ended right away. Yeah, please make one for me if that works. Thanks, Eric. I must have screwed it up. Okay, yeah. So for today's, so a bit of context for today's sys design. This is gonna be a bit more of like a beginner, like entry level kind of problem, and I'll be working very collaboratively with you, Angela, on this problem, so we can get through it together. The
Okay.
basic prompt for today is that we're going to be building a tiny URL. Okay, so have you used any URL shorteners before?
Yes, I have used Bitly before.
Yeah, so Bitly is the same thing, right? So this is like a website. This is the front end, right? We're going to be designing most of the back end. So the purpose, right? The
Okay.
goal is that we want to be able to host and serve a website, right? And by the way, you can draw and take notes as you need. So we're going to be
Oh, okay.
yeah, so just to familiarize that, there's a pen. Okay, you can draw that one. That's for penning. There's also this A character for text. You can draw a text box and just type here. Right, so that's gonna be what's going on.
Oh, okay.
Yeah, exactly.
Okay. So,
Okay, so you can use the tools at your
okay.
disposal, and if you need me to slow down as well, just feel free to let me know, and we can work at your
Sure.
pace.
Okay.
Great. Yeah. So today's so again we're gonna be making a URL shortener like tinyurl or Bitly or whatever you prefer. And the goal here is to be able to serve a website which has this functionality, right? So in this case, we want the user to be able to, put in some long URL or some arbitrary URL, right? And we want to be able to shorten it. We want to give the user a shorter version, like fewer characters. This is to be specific, right? We want to return a URL with fewer characters to the user. And in the future, if the user were to go to that shortened URL, we should give back the long URL. So it takes an input.
Okay.
If it's a long URL, we give them a short one. If it's a short one, we give them the original long one back.
Okay. So I guess those are like the functional requirements.
That's right. Yeah, that would be essentially the front end functions that we want to be able to support.
Okay. And then going on to like the non-functional,
Mm-hmm.
um, I guess we want like a low latency and like high availability.
Ideally, the low latency would be good. If
Okay.
we can get that as like a benefit, that'd be great. But
Okay.
I would say the most important thing would be let's just come up with an architecture first, anyone.
Oh, okay. Like something that works.
Yeah, just
Okay.
something that works, and then we can discuss what we might think the bottlenecks are, and then we can iterate from that
Mm-hmm.
point onwards. But I want to just kind of spend the first little bit just to be able to come up with an architecture.
Mm-hmm.
So I think you taking pretty good notes on what's going on so far about the functional, and we might have some more non-functional requirements later on, but we don't need to worry about. We
Mm-hmm.
can get rid of my welcome to, by the way. Boom. Um,
Okay.
so let's from this kind of from this kind of prompt so far, what kind of considerations are still not known yet? And so, for
Mm,
example, what are some things that might influence which like what direction you go for a design?
we also want like the short URL to be unique. So
Mm-hmm.
if it's already used, they can't use that anymore.
Definitely, yeah. So the short long URLs they should be one to one, right? So one long
Mm-hmm.
URL should correspond to exactly one short URL, and vice versa. One short URL should correspond to exactly one long URL. Yes, that's right. And for this,
And also just like,
oh yeah.
okay. Okay. Sorry, what were you saying?
I was just mentioning that yeah. So this is good. Um, let's figure out exactly what system we are designing first, right? So notice that so far this is sort of like the functional requirement as in what the user is expected to interact with, right? Um, in this
Yeah.
in this problem, we won't be worrying about any user interface or user flows at all. We'll just be assuming that, for example, you have a partner who's making the front end, and you're tasked with making the back end, right? And so I would say that the level of abstraction that we should be working with here is where you will receive an API request from the front end containing uh, containing just, for example, a string which corresponds to the short or long URLs. So we don't need to
Okay,
worry
so
about any of the front end kind of interactions, just from the API onwards.
I guess like the APIs that we might use is when the user asks for like a short URL. And so that would be uh I guess first they would have to like specify like, okay, so what is the long URL and what is the short URL that they want, right? So when they give like a long URL,
Mm-hmm.
I guess that would be like a post for like creating like a short URL.
Sure, sure. I mean, one thing I want to point you towards is that you might not necessarily know, like, how would you know if a URL, for example, is a short or long URL? Have we decided on what our format is
Oh,
going to be first?
oh, right. Okay. Um,
So one thing we can think about here is, for the purpose of this, we can just we can start by determining how we want to store the data model, right? So maybe we can think about what data are we actually interacting with. What kind of
mhm.
database are we going to be thinking about in this context? Do you have a preference for SQL or no SQL?
I don't really have a preference, but I think for NoSQL it might be better because we could scale it. For example, like Cassandra, they can handle like really big scale.
Mm-hmm.
Well, as for like SQL, we might have to do like scaling with like sharding or like federation.
That's fine. We can start with NoSQL if you want to do that. That's not a problem.
Okay,
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 let's sketch out a database here. For database, all databases, SQL or not, we need a key, a primary key.
mm-hmm.
So in this case, what kind of ideas are we gonna have on this one? What should the what should we be thinking about in terms of a row? We can put it that way.
So for like the primary key of the database, I guess we could make it like the short URL itself.
Okay.
And then like the other column would be like the long URL.
So one short and one. So in this case, the key you said is a short URL. Okay. Can you do
Yep.
you want to sketch it out?
Okay. Yeah, I was gonna like underline this, but I'm not sure how, so I'll just write like primary
That's
key.
fine. I mean, you can. Yeah, that's fine. It's not a big deal. Is this your first time using a SkeleDraw?
It's actually not my first time, but
Okay.
the last time I didn't do much with it.
Okay. No worries. No worries.
But yeah, I'm like
SkeleDraw is a pretty
pretty
common tool used for collaborative sketching. So for those in the audience,
and then
I
for
would
like
learn
the
how to use it if I were you.
and then this is like the long URL.
Okay. And what types are they going to be?
For the long one, I
Or
guess
for
it'll be
both?
like a type long. Oh, for both?
Yeah.
So
Like
they're like the same?
I mean, well, for either one,
Okay,
like
so
tell me the types of both ones, because you tell me the name of the field, but what type are we storing in the database? For example, integer,
okay,
long, string, blob.
We could do long, I guess. Just so that it's for short URL. Maybe it'll have like 7 characters.
Okay.
So we could use. Do we have to make them like both like the same type?
Nope, nope. They can be different. They can be any ones you prefer.
Okay. I was thinking of using like a string for short URL
That
and
makes
long
sense.
for the long URL.
That makes sense. In this
Okay.
context, I think using string for long in this context means a long integer. I think you're looking for the word long string, but strings can be or varchar as they are known in the SQL world. But yeah, I think in this
Oh,
case
okay.
using strings for both makes sense, right? In strings in this case, we can for example um, we can for example assume that short URLs these ones so notice that short URLs we control, right? So we control what keys go in here, right? And so we can say for example if
Yeah.
our company, let's just call us TCN, that is terrible writing, TCN dot our domain name, just call it .com, okay, and then we can put
Mm-hmm.
our shortened URL over here. So for example, we might say like 123, for example, doesn't matter. So over here we can
Mm-hmm.
store, that is terrible. So over here we can store this key over here, right? Now one thing I want to note is
Yeah.
that so you pretty said pretty good intuition that we can control the length of how long this key is, right?
Yeah.
And you can say, for example, you said it was length 7. That's fine. It's not a big deal. Now the thing is, the long URL we can't directly control the length of, in a sense, right? Because
Mm-hmm.
the user can put in any arbitrary URL. So for the purpose of this
Mm-hmm.
exercise, we'll just say that if a URL is longer than 200 characters, we can just say that, oh, your URL is too long, we don't support it, whatever. In this context, we can move on with this for now. But I want you to, in the back of your head, just think about the fact that your database row has a fixed amount of memory it's allowed, and
Mm-hmm.
therefore with this method you can't support arbitrary length URLs. So I want you to just keep that in mind. And if a solution to that
Okay.
problem comes up later on, we can come back and address this.
Okay.
Okay, I'm happy with this table structure. So the primary key in this case would be like 123, and then a long URL might be like Amazon.com. That's my pen's too thick. How do I change it? Okay, where's my? Let's just do it this way. Oops. A. Right. So we can proceed with this for now. Okay. So we have a database here. What's going on with the database? So what systems will be interacting with the database here?
So our server will be getting like the information if, for example, like the user asks for like a short URL and they want to get back like a long URL, then our server will like request that from our database. And also when the user first makes like okay from like a long URL, and they want to set like a short URL, we'll also be putting that into the database.
So one thing you said here is the word server. So I want to
Mm-hmm.
make a server here. Can you tell me more about
Okay.
the server? What's going on here?
Okay. So for the server, it'll be requesting like data from the database, and we'll also be putting like data on the database.
Okay, so the server somehow. Oh, these are not grouped together. Can I group these together? Um, Group selection. So we have a server here, right? This ser That's not
Mm-hmm.
grouped together. Whatever. So the server here, it's somehow connecting. It's touching the database, right? It's getting data from the database. Will the server
Yeah.
just be directly reading from the database in this context? In other words, you have a piece of code on this database. Sorry, on the server,
Mm-hmm.
piece of code on the server. We can call it the web server.
Mm-hmm.
Is this, and we're saying in this case the web server is going to talk directly with the database. Do you want to just model that out a little bit? So let's say, for example, our server here. I don't know. I'm not color coding this very well, but I'm using blue for the server. So we have a web server process. Do you have any thoughts for what technology we might use for the web server here? Not a big deal if you don't.
Mm, no, not sure.
Yeah, we can just say it's using Nginx, Apache, or whatever it is. That's not a big deal. So we
Okay.
have we have our web server process, and it needs to do some stuff. right? Can you tell me what are some requirements that this web server has to perform?
Yeah, so their server to be able to like put data like on the database and also get data from it.
Yeah, so it performs read and write requests to the database. And how does it know whether it should, talk to the database? In other words, what's on the other side? So if our flow is something's over here, we have to talk about my drawing. Something's over here, talk about that later. It hits our server. We have our
Mm-hmm.
web server process on the server, and it does some stuff. We can talk about that in more detail, right? It does some stuff, and then you're saying
Mm-hmm.
that depending on what it is, it has to read or write to the database.
Yeah.
Okay. Let's elaborate a little bit on this read and write flow a bit. Okay. In
Mm-hmm.
what context will it be reading? So, for example, if the server receives this string as an input, tcn.com/123,
Mm-hmm.
are you gonna read or write? What's the move here?
Well, we're gonna uh read. Like we're gonna look for like the long run. And give it-
Sorry, Casey, I think you cut out a little bit there.
Oh, sorry. Yeah, so for example, if we get like a short URL,
Uh
then
huh.
we would want it to read like the long URL.
Okay. And if you get the long URL, for example, if the server comes in with amazon.com/product123.
Uh, okay, that one I'm not too sure. So for example, we have like the long URL.
Mm-hmm.
I guess we could like search like in a database if we have like that long, the same like long URL, and then we could return like the short one. But like the part that I'm not sure about is like when do we like actually put like the long URL and the short URL like as a pair when they are first created?
Well, so you in this context, we're saying that the short URL is the key. Is that the
Yeah.
context? Okay, so this is a problem that we run into, right? So we're given a long URL. With the current design, you don't know if this URL has previously been shortened before,
Mm-hmm.
right? Now, to get us out of this hole, I'm gonna just say this, which is that you don't need to know. Just make another short URL. And here's the thing. Here's one thing which I'll tell you as a bit of a hint, is that if you're given a long URL, let's say for example the long URL we're given, right? So I'll draw a little bit about this. Let's say we're given a long URL. I'll use orange. Hope you're not colorblind. If you are, let me know because I'm just kidding. I'm just playing with colors. So let's give it a long input,
Oh
right?
my God.
Is amazon.com/product123. Okay, and we want this to be able to return a short, which is going to be tcn.com/123. Or actually, that's a bit not. Let's do it is A5H. Okay. So in this thing, what I'm saying is that to calculate the short URL, we don't need to make it random, right? Let's just say for the purpose of this exercise, that to determine the short
Mm-hmm.
URL for any long URL, we take the hash of the characters. Okay. So let's say
Mm-hmm.
we compute a hash called the MD5 hash. Okay, don't do this in real life; you'll get hacked instantly. Let's say we perform the MD5 hash, and it gives us this equals A5H. Okay. So in this case, we can just say, hey, we don't actually know if this product has, if this URL hasn't put it in our database before. Let's
Mm-hmm.
compute the hash of this entire long URL anyways, and then see if this or not, and then see if this the resulting hash is in our primary key.
Oh,
Right. This way,
okay.
if someone gives us the same URL twice, we'll compute the hash and we'll see that the hash already exists as a primary key. So that way there's no duplicate data being stored.
I see.
Okay.
Okay.
Okay, cool. So in this case, we kind of, this is still correct. We can still handle the case where someone gives us a pre-existing URL, someone gives us a long URL, a short URL. Okay, so this is sort of we can kind of categorize this, our previous discussion here, just as the possibilities of input space is another way to put it. What's the input space of the web server process? Okay.
Mm-hmm.
Okay, great. Uh, so that's the read, and that's the so that sorry. So this is the write. This is the write, right? So we're given a URL, a long URL. We're gonna write it to the database, right? Or if it already
Yeah.
exists, then what do we do?
We'll have to like let the user know that they can't use the same like long URL? Is this already like taken?
Well, that's one approach we can do it. So, for example, if we didn't let people submit the same URL twice, that would be what we would do. In this
Mm-hmm.
context, if our only requirement, our only function requirement, is given a long URL, give a short URL, we can just give them the previously generated short URL, right? So in the
Oh,
right, so keep in mind in this case, um, it's okay if two different users or all the users all give the same long URL. Maybe it's a really popular URL. Maybe it's google.com or something. Um, but in that context, it doesn't matter if we all give them back the same URL because they all want to go to google.com anyways, right? So in this case, we call this a collision as not being a problem. So collisions are not a
okay,
problem. People can give the same input,
okay,
and if we give them the same consistent output, everything's cool, everything's good.
okay.
Okay, great. Um, okay, so it makes sense so far. Can you tell me a little bit about given the current example, what some limitations are going to be? So in this case, we determined the correctness is good, so it's correct. That's fine, right? Barring any issues with MD5 causing collisions, which we can ignore for this problem, it's going to be correct, right? But this is system design, not are you correct design. Can you tell me about what some of the risks you see with this system are? So maybe if this could be things that you see are performance limitations, or availability considerations that you might be talking about.
Yeah, you mentioned like at the beginning if
Hmm.
we're using MD5 in real life, we would get hacked.
Yeah, so the issue with MD5 in this context, and this is an issue with I would say all hash algorithms, is that if you take
Mm-hmm.
hash algorithms work by taking an arbitrary size input and converting that to the same fixed size output, right? So you might remember that from one of your CS classes. That is one of that's a difference between, for example, hashing and encryption, right? Encryption is reversible, and hashing is
Yeah.
not really reversible for all intents and purposes. What this means is that it's possible that a second link, such as, for example, we can call it google.com, for example, it doesn't really matter, right? This can also, by chance, produce the same hash, which is A5H, right? And so what this
Mm-hmm.
means is, so we can talk about this case a little bit in detail, right? This case, let's say a second, so the first user comes over here. This is user one. This is user one. This is put it here. User one, make that blue. User one comes in and says, "Hey, I want to convert the log input Amazon.com/product 123." Okay. So I'm
Mm-hmm.
coming to your service and I want to do this, right? And what do you say? You say, okay, a response, tcn.com/f5h. Okay.
Yep.
Now in this context, if a second user comes along and requests you to shorten google.com/product123, can you tell me the issue with the state of the database at that point?
Okay. So when we have like google.com slash product 123, then I guess we'll also like return like the same thing, right? pcn.com slash data.
Yes, it will return the same thing. That's right. And then what happens if user one tries to use tcn.com/a5h?
They might get like the google.com like slash product 123 instead.
That's right. They will get that one. Hmm. So that's going to be an issue, and that's going to
Mm-hmm.
be a bit of an issue because depending on, for example, in this context, you can think about it this way: if user one was malicious, what information did they discover from this example?
So they know that like um any URL like so they might know that we're using like the MD5 and so they
Yeah,
can
they might.
also like
Yeah, they might.
modify like whatever they search for.
Right, there's a couple things here, right? So you were, I think, you're on the right track for that thought, right? The issue here is there's two things. The thing they literally know is that
Mm-hmm.
someone else shortened a link with the same MD5 hash as Amazon.com/product123. That's what they know. Now, what they can derive from that, first of all, is what hash you're going to be using. That's the first thing they can derive. The second thing they can derive is the fact that, for example, you can imagine that someone, for example, sends out a survey link, right, to collect some data.
Mm-hmm.
Oh, this is a healthcare survey, blah, blah, give me your SIN. Never do that online, by the way. And then
Mm-hmm.
someone says, oh, I see. You have used this service that uses MD5 hashes to generate short URLs, and I know that people are inputting the SINs into your survey. So what will I do? I will go to your survey, I will copy your survey exactly, and then I will manipulate my URL such that it will cause an MD5 hash with your URL. I would then use your service to shorten my malicious URL to redirect people, instead of going to the real survey, to my survey, because your database doesn't have a difference between the two. See what I mean there?
Oh.
And so
Mm-hmm.
and so and so now people are giving me their SINs instead of the researcher, right? So
Mm-hmm.
that is an issue that can happen if you're using a hashing algorithm like MD5, which is not very secure, and if you're hashing only on user input. So a question I can give
Mm-hmm.
you here is, okay, so this is a problem, right? This is a problem. This makes sense. Now, what are some ways we can use to solve this potential risk, this security risk here? Right. So think about this context. This risk only arises when the input to MD5. So that's this guy over here, right? Let me go green. I like green, right? So this is our input to the MD5 algorithm,
Mm-hmm.
and this is entirely user input. Okay. Do you see what I mean? This is entirely
Like
user
the
input.
green part?
Yeah. So we're saying, so which programming language are you most familiar with? Java,
I'd say
Python,
like
JavaScript. Anyone?
JavaScript.
JavaScript. So you're in
Mm-hmm.
JavaScript. You can import crypto. Okay, you can do import crypto, import crypto. Don't do crypto yourself, by the way. But anyways, you can call, okay, whatever, and then hash MD5, and then say user input here. Okay, this is what our web server is doing. Now, the reason
Mm-hmm.
this is a risk is because uh, the user can fully control our inputs to MD5. You see what's going on here? And
Yeah.
so, the the obvious, maybe a bit of a dumb, but maybe an obvious solution to that is that we don't let the user input be the only input to the MD5 algorithm. Can you think of a
Mm-hmm.
way to add non-user input here?
Mm. So instead of like only like the user input,
Mm-hmm.
will we also have like something like on the URL that we generate ourselves?
Yeah, we could generate.
Is
Yeah,
that
we
like
can. Yeah,
the
exactly. We can generate something ourselves. So that is something that we
okay.
can. Yeah, that is absolutely something we can do. So can you elaborate on that idea a little bit more?
Yeah, so I guess we'll still be using like the user input, but like after taking that in, we'll also have like not just like only what the user put in, but we'll also add like some of our own. So there maybe like
Okay, I
um
like where you're going. Some of our own what? So what are you putting in here? So if you imagine you're making this system called to MD5 hash, or whatever it is, it doesn't have to be anything, but just spitballing here. You're saying you can put our own stuff here, in addition to the user input, or we can replace it entirely. That's up to you. But what is something you can put in addition here?
mm, let me think about that.
Okay, maybe I can ask you something in general, which is that we usually picked MD5 because MD because hashing, because hashing guarantees the same size, same number of bits or same number of characters, string characters output for any size input, right? Now let me ask you this: is there any other ways to come up with a string of a fixed size output given a arbitrary size input? because a hashing example was something I gave at the beginning, but it's not necessarily something which is the best choice for this job.
Mm, I'm not too sure.
Yeah, no worries. One thing we can think about here is by actually decoupling our requirement to have one short URL correspond to exactly one long URL. In other words, every short URL has to correspond to exactly one long URL, right? That's the risk we saw over here, which is that user 2 used the same short URL and got a different long URL. That's a problem. But if the same long URL corresponded to multiple short URLs, that's not actually a security risk. Because if you have any one of the given short URLs, you don't necessarily know anything about the other short URLs. So in other words, we don't actually necessarily need to consider the case that people need a unique one-to-one URL. And so, can we think about what happens if instead of using MD5 to generate a short URL, we just generate a random string of, let's say, 3 characters long, or just, for this context we use 3 characters. In reality, you might use a bit more, right? So let's say we just generate a random string, 3 letters long. Can you tell me if that would
Okay.
defeat this attack by user 1?
Sorry, so you were saying that instead of like giving like MD5 equals to like A5H, we would generate like a random 3 character string?
Yeah. So previously, our way to generate the shortened URL was to pass in the user
Yeah.
input into MD5. Okay.
Mm-hmm.
Now what I'm saying is that instead of using MD5, so let me just drop a little bit of a diagram here. Oh shoot, I'm doing this thing wrong. Here we go. Orange, boom. So now we're in a long input. Long input. We'll call this 2. Okay, is Amazon.com. Same thing as before. Okay, product 1, 2, 3. There's
Yeah.
no. Hold on. Put it over. I'll put it above. I'll put it above to the right. Bit more room to work with. Okay. And instead of using MD5, so I won't put MD5. So instead of doing this, right, I want to say random. I don't care about the user input at all, actually. Random. Okay, get random string. Boom. How to make this sweater? Boom. Okay. So I actually just completely don't care about the user input. Okay. And let's say now
Mm-hmm.
this get random string returns me a string of a 6H. Wow, very very coincidental. Okay. So now I say, okay,
Mm-hmm.
so now what happens in our database? Can you continue this train of logic? So what happens to our database in this context, in this case?
So our database will um like so Amazon.com slash product 123 will like correspond to.
Do you want to draw that into the database?
Okay.
So the short key and then the long URL as well.
Okay, so we have like this. Sorry. Let me make this. Okay.
Cool.
So this is like the long input 2 and the get random string is 8. Do we know like what the user wants to set the short URL?
Sorry, you cut out there.
Do we know what the user wants to set as like the short URL?
No, the user has no say in the short URL. We determine the
Oh,
short URL, right? So we give them tcn.com/123, or we give them tcn.com/a6h, right? So
oh,
we give that to them. We
okay.
said, okay, if you want to visit your long URL again, and you don't remember what it is, you can remember the short one, which is more convenient for you. That's kind of the purpose of URL shorteners, right? We give you the short one, which is tcn.com/a6h. Okay, in this case, it's about the same length, but example. Okay, um, and then they say, okay, great. Now I want to visit my original long URL. I don't remember what it is. Here's a short one you gave me. It's tcn.com/a6h. Can you tell me my long one? Right. So the user has no say. They don't care what the short URL is. right? So we have full control over the short URL. That's right.
Okay.
Okay, so that looks good to me.
Okay.
This is the right implementation database. Great. Now, in this context, right? So this is cool. Now here's the thing, right? So now we don't suffer from any hash collision attacks because if our random algorithm is implemented sufficiently correctly, we can assume it is in this context. Um, there's no issue anymore because, for example, the malicious user one, they can input a form link. The researcher, they can put in a form link. We give them something, right? So let me sketch this out. Let's say this is a form link, right? Legit formlink.com. We give them, and then we give short legit short. Okay, doesn't matter. Just pretend this is like a random string. It's not. It's clearly not, but it doesn't matter, right? So okay, so that's
Okay.
cool, right? And then a malicious attacker, they have their, they have their fake form link, right? Fakeformlink.com, and they want us to somehow have this be the same for this one, right? That's their goal,
Yeah.
right? And this was previously accomplishable with MD5 because they can mutate this part of their URL to collide with the legitformlink.com. So they were in control of the hash,
Mhm.
right? Now,
Yeah.
notice that we don't care what their input is. We toss your input into the trash. Okay, not actually. We toss your input in the trash, and then we just generate a random string, right? So in this context, our random string for their URL might be whatever.com. Oh, it's not .com.
Mhm.
It's gonna be with slash whatever. Okay, slash whatever, right? This way
Okay.
they can. There's no way for them to be able to generate the same the same random string as us, as for the legit form links. So this is how we would defeat this hash collision attack.
Okay.
Cool. Can we talk a little bit about, in this, at least in this context, what a downside, if there are any, for this approach?
I guess like it depends on like the type of like URL programming that we were going for, but at first like my initial thought for like the URL like shortener would be more like Bitly where the user also gets to choose what their short URL.
Mm-hmm. Yeah, that's interesting follow up as well. So this case, they would not get a say. That would be a downside. That's true. And I mean,
Mm-hmm.
but also in the previous hashing one, they would also not get a say. But that's right. Now we can talk about that one a little bit as well. But I want to get to, before we get to letting the user choose their short URL, I wanted to talk a little bit about some other practical downsides that this random string approach would have. In this context, what would happen if the someone like legit person, like they would not, now we're talking about all legit people, okay? So no more malicious actors here. If a
Okay.
second person put in the same long URL,
So we would generate like a different string,
that's right. So for
but
example,
it will, yeah.
someone else might put in the same thing, right? Amazon.com/prod.123, and
Mm-hmm.
we might not, and we definitely, I mean, almost certainly we will not generate A6H out again, right? So we might generate
Yeah.
A7H. That's not how random algorithms work, but let's just say, okay, A7H, boom. All right. Can you tell me a
Mm-hmm.
potential downside for this kind of approach in this context?
It might be like a waste for our database, I guess, because we're
Yeah,
storing like the same phone URL.
yeah, definitely. Yeah. And this, right, the major downside here is just that, if there's a popular long URL that the people want to keep bookmarking, maybe it's a Taylor Swift concert tickets or something, everyone wants that shit bookmarked. But then what will happen is that
Mm-hmm.
for every single person that tries to shorten the Taylor Swift tickets URL, we'll need to store another copy of that in our own, uh, like in the database.
Mm-hmm.
Great. Okay, let's spend a bit of time and transform this problem a little bit, such that the user can try to, the user can propose a short URL. So this is the idea that you were talking about just a moment ago, right? Can you tell
Mm-hmm.
me in this context, if you look at the left again, so you usually have the function requirements. Can you tell me what changed on the functional side?
Uh, so if they give us like a short URL, then we have to give like exactly like what they put like previously. Instead of like returning them like a shorter URL, they would like uh also input the shorter URL.
Right, so the user would input both a long and a proposal for the short URL.
Mm-hmm.
Okay, so let's talk about that then. Um, Great. So someone imports a long URL and a short URL. What happens in this context if the short URL is already taken?
Yeah, so we'll also like let the user know that they can't use the same short URL because it's already taken.
And how would you know if it's taken in this case?
We'll have to like search for like our database and see like look for like our like primary key short URL if it's already there or not.
Okay. And what if someone wants to input a short and long URL, and the short URL is unique, but the long URL is taken? Then what should we do in this case?
Mm. So we still want like to fulfill like, the user's request of like choosing their own short URL, right?
Mm-hmm. That's fine. Yeah, we still want the service to be functional. That's right. Yeah.
But like in our database, we'll have to like do something. Um, or we could also like if the long URL is the same,
Mm-hmm.
can we? So for like the short URL that they have, can we like change it in any way in our database just so that it'll have like the existing short URL and like the long URL? But when they ask for like the short URL that they specified, it will we will like use this this row that we have.
But how would you know which one to give them? How should you know if you give them the direct conversion or the quote unquote like one hop away? Right? Like, what if someone else that wasn't the creator of the URL was using that short URL? Then which one should it return?
Mm. Yeah, I'm not too sure.
That's fine. We can. I mean, there's no way to combat that. Is the answer, right? There's no way to combat that. If your solution is to if your product if your functional requirement is to allow it to happen, right? Um,
Mm-hmm.
in this obviously is way to combat everything, but we're talking about this level interview. One thing I will say is that consideration I want to see a bit more about is that we can just chat for a little bit more. A little bit more. We can do maybe three to 5 minutes more of this, and I'll give a bit of feedback at the end. But one thing I want to follow up on is that sounds reasonable as an approach, right? If the long URL is already taken, but the short URL, just give it to them, right? Just let them make another short URL entry, right? Just note that in that context, in that world, um, the this is the same as before as the random strings, which is that multiple long URLs, no, sorry, the same long URL can have multiple rows in the table. So
Mm-hmm.
it's the same. So yeah, it's a different functional requirement now. Notice, but the actual database table becomes the same. It approaches the same complexity, right? But at least for the
Mm-hmm.
complexity, it's a compensator, right? At least now it's the same complexity, but the user gets a bit more feature, gets a bit more functionality out of it. So that's still cool.
Okay.
Now, one thing I wanted to just kind of touch on at the end here before we wrap up is that you mentioned previously that for the database layer, let me just get my pen out. Let's make it green because I like green. This is the database layer. You want to put this in Cassandra. Is this what this is? I believe. Correct
Mm-hmm.
me if I'm wrong. If I misheard you, let me know.
Yeah, what did you say? Sorry.
The database layer you previously said as a key value store you wanted to use a product like Cassandra. Cassandra.
Mm-hmm. Yeah.
Okay, cool. Um, and the so that sounds good to me. Now, where would that be running on? For example, is Cassandra instance running on the same server as a web server, or is it running on a different server just for databases, or where would this actually be? hosted on?
I guess we could use like a different server
Okay.
just for like the database.
Okay. So we have a server for. So we have this. So Cassandra is a separate host, and your web server here is
Mm-hmm.
its own host. Okay. In this world, can you tell me some of the failure modes possible for the system?
Like failure modes, as in like why this will fail.
Failure modes, as in, what are some imaginary situations you can come up with that would cause the functional requirements to not work, to break?
Mm. I guess when like there's like too many users asking for like URLs,
Mm-hmm.
our server might not be able to handle it.
Okay, so one of the yeah, so that's a good call out. So one bottleneck here is going to be I'll use what I've used all the colors already. Fuck me. I'll use red. So one the consideration is the web server process gets overloaded, so I can't handle oh my god, what? Oh, I'm using the background. Wait, what am I doing? Solid color pen. Okay. Boom. One. Okay. One thing is the web server process can be overwhelmed by the throughput requests. Okay, that's one thing.
Mm-hmm.
Anything else you can think of?
Mm. Also, our database might get too long.
Okay, the database could get overwhelmed. So database in this context, the only thing we're using the database for is read and write. So that'd be this layer
Mm-hmm.
here. Okay. And by overwhelm, you're talking about specifically about the performance of the database. So for example, if our web process, a web server process was scaled vertically, so it was a very powerful web server for whatever reason, and we were making a lot of requests to the database, and it couldn't keep up. So the processor or with the stack on the host cannot keep up with the request made by the server. That is another failure mode. What if the internet went out? What if we had some networking issues? Can you tell me where that might show its face?
Yeah, if like if the internet went out, then we also might not be able to provide our service.
Okay, and in this context, I think we're talking about the networking between the server and the database. So, for example, if these were in separate networks, for example, the server you host
Mm-hmm.
it on AWS, and the Cassandra you host it on, I don't know, GCP or something. If there's a networking fault between the two data centers, then that might be an issue. Or, for example, for some reason,
Mm-hmm.
if your Cassandra instance was hosted in a different country, and then there was like a thing there, and then yeah, so that's another issue is that if networking stuff happens, your web server might not be able to connect or reach your database. And of course, the networking,
Mm-hmm.
if your user can't touch your server, then that's out of the scope of this question, so we don't worry about that. Okay, and
Mm-hmm.
the last thing, well, I think it covered most of the bases here, so I'm happy to kind of pause here for this mock interview. Let's pause here. Any maybe some just opening comments from you about how you feel, and then I'll go into some of the things that came up from my side.
Yeah, I feel like I learned a lot from this session, and I also realized that like a lot of like system design interviews are like structured super differently, like according to like your interviewer. And yeah, I definitely need like a lot more. Yeah, those are all from my side.
For
Thank
sure.
you so much for like holding this though. That was really
Yeah, no
helpful.
worries. I think a lot of the system design interviews are structured differently because the goals of interviews are different, right? So, for example, if
Mm-hmm.
you go to YouTube right now and you search system design, YouTube or whatever big system you can think of, right? Those will be pretty idealistic interview sessions or mock interview sessions. They always won't be real interviews. You can't record those. Like they'll be fairly idealistic interview sessions or mock interviews for essentially what is a complex system that someone who knows how to design will design, right? If you if it's
Mm-hmm.
a mock interview of a tough system with someone who doesn't know how to design, that interview will not make it very far at all, and that will probably not make it onto YouTube, right? So keep in mind that videos you see online are fairly idealistic. And what that means is if you encounter a system which you are not familiar with, or a technology that you don't know how to approach, you need to change gears and kind of focus on what you do know, what you can focus on, right? So use those as a reference, but don't rely on that format.
Mm-hmm.
It's yeah, it's very personalized. And another thing is you got to remember that, like for example, interviews like lead code interviews, or even to some extent OOP like object oriented design interviews, those ones have one singular purpose, which is like, okay, how is your technical skill and how is your collaboration, communication, explanation skills? Okay, like that's something they can really test for a pure problem like this. But a systems interview is one which tests both your technical knowledge as well as the depth of your technical knowledge, right? So, for example, for the beginner level, we might expect that you know about services, you might know about databases. It's a bonus if you know about NoSQL databases, by the way, props for that. But and I was looking in the chat. I couldn't respond to people in the chat, by the way. I was too focused on this thing. But I saw people talking about, oh, all these different properties about databases you can configure on that stuff. That's going to be firmly out of the scope of this intern slash even new grad type interviews, because that's not something which people should be evaluated on whether they know, right? Like, do you know about quorum rights? No, you don't. Is that a bad thing? Probably not. Like, which third year knows about quorum rights on Cassandra, right? So like that's not so, right? So that's something which you might expect someone to know, at a senior level at Meta, right? That's something which okay, you need to make this thing work. You have to know how this thing works, but at this level, like we're designing something that's very high level, we're much more focused on the correctness of the approach than specifics about the performance or availability. And the fact that you were able to identify a couple instances or a couple failure modes, that's what they're known, right? Failure modes isn't how things might fail if they were to fail, right? That's sort of like at least
Mm-hmm.
recognizing that there are shortcomings to the approach, and you might not need to know how to solve them, right? But if you can identify what the shortcomings are, that's halfway to solving the problems in the first place. So I don't think that's a downside at
Okay.
all. I think the biggest thing here is to brush up on uh, the major components, right? The major components of systems. So in this case, you got a web server that makes 4 websites. That makes sense. Database that makes sense. Some other things you might want to just touch up. I think I shared some resources with you and some others before. But one big thing is that all the different layers. So networking layers. What are the networking layers? What are the API layers that I'm going to be talking about here? Right. If you're talking about a database, one of the things you want to think about is a cache. Right. So what are we? How can we save read write cycles from database? Performance wise, like once you get to talk about performance, that's when a lot of that kind of opens up a whole other can of worms, right? So that's something which you want to think
Mm-hmm.
about. But after you get through some of the more basic layers. So I think for this
Okay.
level is well done, but there's a lot to, of course. I mean, there's everyone has a lot to work on. So I think this is something which you can definitely take home some lessons from.
Thank you so much.
Awesome. Okay. Thank you. Thank you very much. Take care.